there, Math Hoppers. In this video lesson, we will learn how to solve quadratic functions in their simplest form by determining square roots or simply using inverse operations. Alright, so even though they will be in their simplest form, in order to solve them, we need to first talk about what is a quadratic function. In its standard form, a quadratic function is written as ax squared plus bx plus c equals 0. You will notice this highest exponent of 2 is your clear indicator that you are dealing with a quadratic. And in order to solve, they need to be set equal to 0. You'll notice sometimes you're given a quadratic not set equal to 0, and you will need to take the steps in order to make it equal 0. A clearly cannot be equal to 0, because then we would have no quadratic term and we would not have a quadratic function. All right, A, B, and C are simply real numbers, and A is called the leading coefficient. It is a term we use fairly often from here on out, so it is good to know. When we graph quadratic functions, we get a graph that is called a parabola. It either opens up or it opens down. There are, however, graphs of parabolas that open to the left and right, but they are not quadratic functions, and they are covered in a different unit in algebra. Quadratic functions in simplest form. So what is its simplest form? What's the easiest form of a quadratic? Well, the simplest form is x squared equals d, where d is simply a real number. When we are given these, and in fact we are going to solve some right now, we simply use inverse operations. The only thing you have to remember is what the inverse of squaring a number is. So consider this equation, x squared equals 9. X is not isolated on one side of the equation. It may look like it is, but x is not alone. We have a power of 2. We need to get rid of that. So the opposite of squaring is square rooting. This is something that is key to solving quadratics. Remember that the opposite of squaring a number is square rooting, or taking the square root, not dividing by 2. So since the opposite of squaring is to take the square root, we will take the square root of both sides of this equation. The square root of x squared, remember anytime you square, you take the square root of a square, those are inverses, so they simply negate each other. The square root of x squared is x. The square root of 9. Now there are 2 square roots for 9. Every positive real number has 2 square roots, positive 3 and negative 3. So this little plus minus symbol represents 2 solutions. This x equals positive and negative 3 represents 2 rational solutions, the solution positive 3 and negative 3. Think about it. If you square 3, you get 9. 3 times 3 is 9. However, if you square negative 3 times negative 3 is also 9. Remember, positive real numbers have 2 square roots. Let's look at another one. We have x squared equals 7. Again, x is not isolated on the left side of the equation. There is a square with it. We must do inverse operations, so let's take the square root of both sides of the equation. When we do so, we get the square root of x squared equals the square root of 7. Now, this is a little different than the last one in that there is not a whole number rational solution to the square root of 7. Square root of 7 is in fact irrational. So we simply write that x equals the positive and negative value of the square root of 7, or positive and negative rad 7. This represents 2 irrational solutions, both the positive square root of 7 and the negative square root of 7. Let's look at x squared equals 0. X, again, not isolated on one side of the equation. We need to remove the squared by taking the square root of both sides. But what happens when we take the square root of 0? Well, the square root of 0, let's think about this. 0 is not positive and it's not negative. Therefore, the positive and negative solutions don't exist here. The square root of 0 is simply 0. 0 is the one number that has one and only one square root, and that is 0. So when we take the square root of both sides, we get x equals 0. This quadratic has only one solution, and that is x equals 0. All right, let's look at x squared equals negative 2. Once again, x is not isolated. We have x squared, so we must take the square root of both sides of the equation. And think about this. What happens when we take the square root of a negative value? We learned this in Algebra 2. When we took the square root of negative 1, the square root of a negative number does not exist, so we have a mathematical invention called I. So let's look at this. We take the square root of both sides, and we have to remember that -2 is equal to -1 times 2. And the square root of -1 is the imaginary number I. So we essentially pull out the square root of -1 and rewrite it as I. The square root of -2 is positive and negative I rad 2. Okay, this represents two imaginary solutions, positive I rad 2 and negative I rad 2. So if you need to refresh your memory on the cycle of I in imaginary numbers, you want to go back and look at the video in Algebra 2 on the cycle of I and imaginary numbers. But just remember the square root of -1 is positive and negative I. Okay, let's look at them now. Maybe not in the easiest form, but we can still solve them by using inverse operations. And why can we do that? Because we don't have an x term. So here we have an x squared term, so we have a quadratic term, and we have a constant, but we don't have a linear term. When we don't have a linear term, we can simply solve this using inverse operations. Remember to work furthest from the variable first. So we first need to eliminate the constant. The constant is -24. The opposite of -24 is +24, so we will add 24 to both sides of the equation. When doing so, we get 4x squared equals 24. Remember, we're still not taking the square root. We still have to get rid of this coefficient, this 4 times x squared, before we can get rid of the squared. So use inverse operations to eliminate that 4. The opposite of multiplying by 4 is dividing by 4, so we will divide both sides by 4, getting x squared equals 6. Now we can take the square root of both sides. When we do so, we see that the square root of x squared is x. The square root of 6, again, is simply the square root of 6. It is an irrational solution. So we get x equals positive and negative rad 6. All right, one more. 2x squared plus 16 equals 0. Again, working furthest from the variable. First, we have to get rid of the constant. Then we have to get rid of the coefficient. Then lastly, we can take care of the power of 2. So opposite of positive 16 is negative 16. Subtract 16 from both sides. We get 2x squared equals -16. We can kind of see where this is going and that we're going to get an imaginary solution here. But let's follow the steps. The opposite of multiplying by 2 is dividing by 2. So let's divide both sides of the equation by 2. Doing so gives us x squared equals -8. Now we can take the square root of both sides. When we do so, we get the square root of x squared equals the square root of -8. Let's break down the square root of -8. The square root of -8 is equal to the square root of -1 times the square root of 4 times the square root of 2. Well, these two things can be simplified. Square root of -1 is I, and the square root of 4 is 2. So that is what we are going to do in this solution. We are not just going to leave the square root of -8. So we get x equals positive and negative 2I rad 2. I got that because the square root of 4 is 2. The square root of -1 is I, giving us the 2I. Remember, they have two solutions, positive and negative. And then square root of 2 cannot be simplified, so you bring that down as the square root. Okay? Once again, remember, square root of I, or the square root of -1 is I, and the square root of 4 is 2. That is how we got that. All right. Hopefully this was a review for you. If this was your first introduction to solving quadratics, there will be other strategies we will learn in other videos. If you have any questions going through your classwork, the quiz after this lesson, or maybe your homework that you got at school, you should be subscribed to our YouTube channel. Please submit your questions there, and we will make a custom solution for you that will help you solve your homework. Until next time, Math Hoppers, take it easy.